All right, so section 8.2, perimeters of composite figures. This is a very short lesson because there's really no new material here. You're going to be finding the distance around composite shapes, which we'll look at in a second what those actually are. They're just shapes that are made up of other shapes. So I'll give you some examples of what that could look like. But first, I like to test your knowledge on circumference. So I've got two story problems that are probably a little bit more difficult than the ones that you've done in your homework. So we're going to look at them together so we can get used to using that formula again before we jump into our composite shapes. Bicycles in the late 1800s looked very different than they do today. How many rotations does the big tire make after traveling 600 feet? Round your answer to the nearest whole number. Have you guys ever seen a bicycle that looks like this? Maybe in a movie or a TV show? And yeah, anyone's ridden on one before? Seen someone ride on one in person? Did you see them get on the bike? How? How did they get on it? That's what I want to know. Is there a step? Maybe they have to step onto the pedal and hop up?
You have like step ladder.
Well, he's like a juggler, so he has like nice.
So he's used, okay. Gotcha.
He kind of just stepped over.
And then just lifted himself up. I feel like I would not be able to get on this bike. I would step up on
I
it.
don't know that I could balance it well enough. Maybe it would be easier. I don't know.
Addison, stand up here for us. Addison, I'm going to guess that your height is about 5 feet. Is that right? Are you close? Do you know what your height is? I'd say she's probably close to 5 feet. You see how tall Addison is? That's how tall the bike tire is. Just to give you an idea.
You'd have to have to step over her head to get on the bike.
Can you imagine having to run? So there's Addison right there. And you're up here. Kind of scary, isn't it?
And to get on it, you probably have to almost step on her shoulder.
Yeah, it's crazy. Now, the reason I say 5 feet is because 60 inches is the same as 5 feet. Do you know how many inches there are in a foot? 12. And so if I take 60 inches, which is the radius or diameter of this tire, diameter, and if I divide that by 12, that means that 60 inches is the same as 5 feet. Now, the reason I'm doing that isn't just because I think Addison might be close to 5 feet, but because in this problem, it says, how many rotations does that big tire make after traveling 600 feet? So I have to convert my inches into feet here, okay? Now, rotations. When you're talking about a rotation on a circle, and we're talking about distance here, we're going to be looking at circumference, because circumference is going to show me how far it is around the circle. So when this bike tire spins one time, from here back to there again, that's one rotation. It's also one circumference. So I need to know what the circumference of my circle is. Does the circumference formula use the radius or the diameter? It uses the diameter. That's perfect because that's what they gave us. So first thing I'm going to do is pi times by diameter, which is 5 feet. Again, I'm using the circumference formula, C equals pi d, and I know d is 5, so I'm just doing 3.14 times 5. Maddie Cheeseman, can you tell me what that's going to give us? 3.14 times 5. I think you did 60. $15.7. Yeah. Now, the reason we're using 5 instead of 60 is because we want to use the feet. We want to use feet for this problem. All right, so in one rotation of that bike tire, I will have traveled 15.7 feet. I need to know how many rotations it's going to take me to travel 600 feet. So how many of these 15.7s is it going to take me until I get to 600? What kind of problem is that? It's a division problem, exactly. So I'm going to take 600 feet, which by the way is the length of running all the way down and all the way back a football field. And I'm going to divide it by 15.7 because every time my tire spins, it's taking me 15.7 feet. Natalie, what do I get? 38. Is it exactly 38? It does. 38.22. Okay. So the reason she said 38 is she looked at the instructions. It says round to nearest whole number. So whole number, no decimal places. 38.2 is going to be closer to 38 than it is to 39, right? So we'll just go ahead and say 38 rotations, not feet. It asked me how many rotations the tire is going to spin. So 38 rotations. That's not a lot, actually, right? To go up and down a football field and your tire's only going to spin 38 times. If you use one of your bikes from today with the obviously much smaller tires, it's probably going to turn 100 or more times going down and back a football field. But these tires are so large that by the time they spin all the way around one time, you've already moved almost 16 feet.
I want to at least try it.
I need training wheels. If I had training wheels on it, I would feel a little bit more comfortable.
How do you stop and get back off? But I'd like to know if it's easier. And I know that the original ones were like wood, so I mean, it would be now with, tires and everything.
The seat doesn't look very comfortable.
Now that looks
Right.
like an original.
It looks like it supports my butt, but if it's made out of metal, that is not going to be very comfortable, right?
I don't even think it would support mine.
You do like bucket grips in the back.
Now think 1800s here. You're going to put a jetpack on it now. Okay. Our next problem is about a clock. It says the length of the minute hand is 150% the length of the hour hand. Now, which one's the minute hand and which one's the hour hand? Lucas?
The hour hands are short.
The hour hand's the shorter one. The minute hand is the longer one. Which one moves faster? The minute hand.
Actually, the second.
Okay, you're true, but I'm comparing just the minute and hour hands. So the minute hand moves faster because it's going to make one whole trip around the clock every
Oh,
60 minutes, which is an hour. Yeah, so every hour the minute hand's moving all the way around the clock, whereas in every hour, the hour hand's only moving 1/12 of the way around the clock if there's 12 hours, right? 24 hours in a day, so it's going to go around twice in a day, right? Okay. The second hand, as Lucas said, would be moving fastest, but we're not going to look at the second hand for right now. So it says, what distance would the tip of the minute hand travel? So there's the hand we're talking about there. In 45 minutes. Now you just told me that in 60 minutes, it's going to move all the way around in a complete circle. So what portion of a circle is it going to move in 48 minutes? Sorry, 45 minutes. Addison?
3/4.
Yeah, it's going to be 3/4. 45 minutes is 3/4 of an hour, right? So in 45 minutes, it's going to move somewhere to about right there, approximately, right? Okay, so it's not a full circle. However, because I'm talking about the distance around a circle, I'm still going to use circumference. So if I'm going to use the circumference of a circle, I need to know its diameter. I don't even know what the radius is because all they give me is the hour hand. I need the length of the minute hand. So fortunately, if we go back up to that first sentence again, it says the length of the minute hand, which I don't know. You guys okay with me calling it M? Minute hand? Okay. So the length of the minute hand is, equals, takes you back just a chapter ago, right? Is 150%. What is that as a decimal, Frank? 1.5, okay? Of times, then it says the length of the hour hand, which is actually given to us as 36. So if I just take 1.5, 150% of times that 36, that's going to tell me how long the minute hand is. What is that, Rayleigh? 54. Excellent. So my minute hand is 54. Michael, could you shut the door for me, please? I know you do that like every day, and I just keep forgetting to remind to do that myself. Thank you. So the minute hand is 54. Is the minute hand the radius or the diameter of our circle? It only goes halfway through, right? Now I want the diameter. So if the minute hand represents the radius and it's 54, I'm going to replace this M with a 54 now. And I want the diameter that goes all the way through. I'm going to need to double this. Ella, what do you get when you double 54? Yeah. So my circumference formula to find the distance around the entire circle is pi times diameter, which is 108. If you didn't hear what she said 108. That's going to give me how far that minute's hand's going to move in one full trip around the clock. Is that what I want? It's not what I want. I want it to go around the clock, but I only want it to go 45 minutes. Addison reminded me 45 minutes was what portion of a circle? 3/4. Do you guys remember doing the doghouse problem we did yesterday in class? For the part of the circle is covered up by the doghouse. We said it was 3/4 of a circle. We're just going to times this by 3/4. So if I want half a circle, I times my circumference by half. If I want 3/4 of a circle, I times it by 3/4. What, by the way, what decimal is that? Maddie? It's 0.75. It's 75%, right? So I'm going to take 0.75 times pi times 108, and I can do that all in one step. I could just times those three numbers together. Why don't you do that for me? Andrea, tell us what you get when you're done with that. 0.75, because this is only 3/4 of a circle, times pi times 108, because that's the diameter of our clock. Well, not the whole clock, but the minute hand part of it. What'd you get? Say it again.
42.3.
You did 18 instead of 108? Okay, I was gonna say it should be much bigger than that. 0.75 times 3.14 times 108. 254 point what? 0.34. Okay, is that what someone else got too? I was gonna say, I think that's what first period got as well. And my answer is gonna be labeled how? Just millimeters. Yeah. Why am I not writing millimeters squared? That's only for area. Yeah, when we're talking about space inside, that's area. Because today's lesson is titled Perimeter of Composite Shapes, we are not going to be doing any square unit labeling. We're just going to use regular units today. Which takes us right into today's lesson then. So those are some pretty complicated problems that you guys, with a little bit of help, were able to walk yourself through. Okay. You didn't see any of those problems on your homework, did you? With a clock having to use 150% and all that stuff. No, but I mean, honestly, if you saw that on an iLearn test, they're like, here's your problem. Show as much work as you can, right? I mean, you can take baby steps and work your way through this problem. If you saw this question on an iLearn test and it incorporates percents and circumferences, you could get a good start on it. And if you make a mistake somewhere, keep going. Keep going. Okay, use that mistake and just keep going. So okay, I'm not sure if this is the right, I'm going to assume the diameter is this and I'm just going to keep going. Like that's how they want to see you actually attack and make it all the way through the problem, not get stuck and then stop. All right, they want you to see, even if it's wrong, they want you to see you go all the way through the problem. All right, so a composite figure is made up of other two-dimensional figures. So we see here in this example, we see a square and a triangle. They say that's a composite figure. I'd argue and say that's not a composite figure, that's just a trapezoid. We looked at some trapezoids yesterday, didn't we? Right, this just so I guess you could say maybe a trapezoid, you could chop a trapezoid up into different figures, so we'll call it a composite figure, sure. The next one, definitely a composite figure. You see a rectangle and then you see a semicircle. So these are the kind of shapes that we're going to be looking at today. Because we are finding perimeter, I'm not interested in the space inside of them. So I'm not interested in using my area formulas. I'm just interested in adding up all the sides. So in a shape like this, how many sides do you guys see? Should be more than 3. How many? There should be 4. And the reason we are saying 4 is because you have to think of that curved edge as one side in itself. So in this particular problem, I would have 1 curved side, and then I would have 2, 3, and 4 straight edge sides. Now the straight edge sides are going to be very easy to add up. It's the curved edges that we're gonna have to use our circumference formula for, okay? So why don't we look at our well, let me fill in the blank here. Perimeter is the distance around. We're looking at the distance around the shape. So you're not gonna hear me say, what formula do I use for the area? You're not gonna hear me say that. You're gonna hear me ask you how many sides there are, and we're gonna add all those sides up. That's how we find perimeter. Okay, so our very first shape here in purple says it's made up of a semicircle and a triangle. How many sides do you see on this shape? How many? I see 3. I see 2 straight edge sides on my triangle. Bless you. 1 and 2. And then I see a curved semicircular edge. Okay, so why don't we go ahead? There's 3. So that means 3 sides means 3 numbers. We're gonna have to add together. 2 of them we already know. 24 plus 10. We're already 2/3 of the way done. We have 2/3 of our sides. The last side, this curved edge, is a semicircular side. And so because I'm talking about the distance around a circle or half a circle, I'm going to be using my circumference formula. And again, the circumference formula is pi times diameter. Do I know what the diameter of my semicircle is? What is it, Hunter? What's the diameter of the semicircle? What's the diameter of that purple semicircle? You just found the radius. The radius is 13. Don't overthink this. It's just 26, right? It's kind of nice when they give you the diameter. Of course, if they give you the radius, I have to get the diameter from that. But yeah, this 26 centimeters, this distance right there is my diameter. So when I'm finding the length of that curved edge, I'm going to add pi times 26 because that's pi times diameter, but that's going to give me a full circle. This isn't a full circle, it's a semicircle. What fraction of a circle is a semicircle? Half of one. So I'm going to take half of that. Now you can save yourself half a second if you know what half of 26 is. Do you know what half of 26 is, Branson? 13. So you just save yourself half a second. Instead of having to type all that in, you could just type in 13 pi. You could type in 13 times 3.14. I'm going to use 3.14. You're welcome to use the pi button. And Big Ideas should accept the pi button answers as well, as long as you're rounding them correctly. And that should give you what, Frank? Did you use 3.14? Okay, try it again. You times by 26, then divide by 2, or what'd you try to do? Okay. So you can only do so order of operations says do the multiplication first, then the adding, right? So we have to do, that's a good point. So I can't just type this all into my calculator because my calculator is going to use order of operation. Well, it's actually my calculator tries to use order of operations. Doesn't seem like it always does. But I have to do this portion of it first. I have to go multiplying before I go to the adding. So if I just do the green part here, the multiplying part, what's that going to give me? Okay, 40 point, you say 85, okay, 84. My 3.14 gives me 82. Okay, but you're welcome to use the 84 because you use the pi button again, right? Okay. All right, so I know that the curved section here, and again, we took half of that. We took pi times 26 and then we took half of that is 40.82. Now I know the third side. I already know the other two sides are 24 and 10. 24 and 10. Sierra, what's 24 plus 10? 34. So I know the other two sides out of the 34, and I'm just going to find this total perimeter now. 34 plus 40.82. Sierra, I'm going to come back to you. What's 34 plus 40.82? That's right, 74.82. Now, how do I label my answer on my board paper today? If this was a homework question, what would I write down? Addison? Yep, just centimeters, just talking about the distance around it. So I have three sides. I have two sides that were given to me, 24 and 10. I have a third side that went around. It was a semicircular side. I had to do pi times 26, divide that by 2, which gave me 40.82. And I just added that third side with the other two. Did 26 get added on? No. I used the number 26 to find my half my circumference, but I didn't add the 26 because the 26 doesn't go around the shape, it goes through the shape. And we don't want to use those line segments when we're finding our perimeter. We just want to go around the shape. So the 26 was necessary for us to use to find the circumference, but we don't want to add 26 to that answer. We want to leave that as 74.82. All right, next one. Says the figure is made up of a square and two semicircles. Find the perimeter. It only gives me one side. Top side is 8 meters. How many sides do you see on this shape? Whitney? There are 4. There's a straight edge side on the top. There's also a straight edge side on the bottom. Whitney, do you know what the other side on the bottom is? How long is that? Also 8. So 8 plus 8, we're already halfway done. And then we have 2 semicircular parts, 2 sides on the outer sides, right? Now, because it said that this figure was made up of a square and 2 semicircles, do we know how long the dotted lines are? How long are they, Maddox? Also 8, nice job. Now, I'm not gonna add those 8s onto my perimeter because those dotted lines are on the outsides, but they are going to help me find the distance of the curved part. So if I have 2 semicircles, what do you think about this? One on this side and one on this side. I want to find the distance around this one, and I want to find the distance around that one. What's 2 semicircles the same as? Just one full circle. So when I'm going to find my third and fourth sides, my 2 curved sides, I'm going to treat them as if it's one whole circle that I'm trying to find the distance around. And so I'm going to use my circumference formula without the half then. So pi times, and then what is the diameter of my semicircles? It's that dotted line, which we just said was 8, exactly. So let's recap. 8 plus 8, top and bottom, 2 semicircles, half a circle makes a full circle. So I'm going to use my full circumference formula, pi times diameter, or pi times 8. Do the multiplication part first. Hannah, what's pi times 8? Awesome, okay. So both the curved edges combined give us 25.12. So I've got that curve and that curve now. Excellent. Okay. Thomas, what's 8 plus 8? Okay, so both the straight edge sides give me a total of 16. Thomas, one more question. Go ahead and add your 16 onto the 25.12 that Hannah just got. That's going to give us our total perimeter. 41.12. And what's my label, Thomas? Meters. There you go. Do you see what I mean when I say that this homework isn't any new stuff? It's just using what we already know and adding it on to some other sides that we didn't have to use back when we did section 8.1. Okay. I'm using the circumference formula, except I'm adding some other sides. That's it. Look at example C. Now, how many sides do you see on example C? Whitney? 6. There are 6 of them. Only 4 of them are given to us. So we're going to have to find 2 of the missing sides first. How many of these 6 sides are curved? None. So what number is not going to be part of my problem? Pi. I only use pi for circles. I don't see any circular parts, so I'm not going to use pi at all for this problem. This is just a typical perimeter problem that you would have had last year, maybe even the year before. There are 6 sides. The 2 sides that we don't have are the bottom part here and then the left side towards the bottom as well. Okay. All right, so what I'm going to have to do is use the lengths that I do have to try to figure out how long these missing edges are. Let's start with the bottom side. Can someone explain to me how I can use the other sides to determine the length of the bottom side? Natalie. That's right, 14 plus 5.5. Now she's using these two sides here, which I'm going to highlight. This side here, which is 14, and she's using this side here, which is 5.5. Together, those two sides have to make this longest side. And Natalie, how long is that long side? I'm just going to say 19.5. Okay. Someone else want to show me how I could find the side on the left, Rayleigh?
Oh, I was gonna say half of it, but that wouldn't make sense.
It's not quite half of it. Do you have any other thoughts on it? So look at this side over here. It's 12.5, right? I know that this side that we're missing, along with this 4-foot side, have to add up to be 12.5. So using that information, how could I find out the missing side? That's exactly right. 12.5 minus 4. 12.5 is how long this side is. We're going to subtract away this part here that we already know is 4, and whatever's left over is going to be that long part. Maddox, you know what that is? 8.5. Now we have all 6 sides. So now I'm going to add them together. We'll start with Maddox's 8.5 plus the 19.5 plus the 12.5. I'm just going around. You can start wherever you want to, as long as you have all 6 sides, plus the 14, plus the 4, plus the 5.5. It's a lot of numbers. Now you have to trust yourself to be able to type those 6 numbers into your calculator with no typos. Thomas, you think you have it? What do you have? 64. Anybody else? Nods, 64, 64. Okay. So our perimeter then is going to be 64 feet. Now, I think an argument could be made that that problem might actually be more difficult than the first 2 that we did, even though the first 2 used pi. You could say, well, I didn't have to use pi, I didn't have to do any extra calculations, but didn't you have to find 2 missing sides and then add 6 sides together? Whereas in our first problem, we only had 3 sides. So using the circumference isn't a difficult formula to use. You just have to know how many sides you have. And honestly, I'd rather do a problem like this one than a problem like this one, where I have to find missing sides and then type them all in. You'd rather do the ones with the straight edges?
Where that sucker up.
All right, example D. Is a square. We know it's a square because the length and width are both 5, with a semicircle on top of it. How many sides do you see? 4 again, okay. 3 of them are already known to us. We know the bottom side's 5. We know the left side is 5. And we know the right side is 5. So we can start by writing 5 plus 5 plus 5, and we have 3/4 of our sides. The one side we don't have is a semicircle side. Maddie Yentes, how would I find the distance of that semicircle side, do you think?
By doing pi times the diameter, and the diameter is 5 meters. So this is
Perfect, yeah. That dotted line is going to be 5 meters, just like all the other sides of the square were 5. Now, Maddie, there's one thing you need to add to this. Is this a full circle? So what?
you,
That's exactly right. Or divide by 2 for those of you that prefer to do that. That's perfectly fine. So my 4 sides are 5, 5, 5, and then half a circumference. 1/2 times pi times 5. She used the circumference formula of C equals pi d, except she put a half in front of it, and she knew that the diameter was 5 because that's the side of the square here we have here. Okay. So half of 5, you could start with that. Some of you know that's 2.5. You could do 2.5, or you could just type it all in your calculator. I mean, it doesn't save you a whole lot of time just to do 2.5. But if you multiply all that out times 3.14, we should be getting, for the semicircular edge, 7.85. 7.85. Now, Michael, if you add on the 3 other sides that are both 5, 5, and 5, all 5, 5, 5, what's 5 plus 5 plus 5? 15. Okay, and one more question. Add on the 7.85 to that, and we'll have our total perimeter. Say it again. 22.85, and label it for me. Just meters. Yeah, 1 m is meters, 2 m is millimeters there. So 22.85 meters. Questions? Again, I feel like if I just gave you shapes like this, you probably would struggle through it at first, but there's nothing here I'm teaching you that you don't already know. I mean, I showed you how to find the circumference of a semicircle back a couple sections ago. Even though the semicircle, you had to find half the circumference and add a side on. Here we have to find the circumference and we have to add 3 sides on. Okay. I mean, really, there's nothing that's new. It's just these problems are going to take you a little bit longer because they have more sides. Right. That's why when you go to your homework tonight, you're not going to see a ton of homework questions because each homework question has lots of sides I have to add on to it. Right. Okay. Let's move into this problem. It says, the running track is made up of a rectangle and 2 semicircles. It looks just like this one we did, example B. Find the perimeter. So based off of the information that they're giving me, I'm going to assume that the perimeter is the outside edge of the grass, because I don't actually know how far it is across the track on both sides. Okay. In fact, that's actually going to be one of your homework questions where they're going to ask you that. Okay. So we'll look at that one tomorrow. But to find the perimeter of this, I first need to ask myself, how many sides does it have? How many sides does this shape have? You should see 4. You should see 2 straight edges on the left and right side, and then 2 semicircular edges on top and bottom. Right, so there's a total of 4, and 2 semicircles makes what? 1 full circle. So that I especially like when they give me 2 semicircles because then I don't have to divide by 2. Okay, so I know, and I guess if we'll just assume, any track people in here, long distance runner, is it lane 1 is the inside lane or the outside lane? Inside. Okay, so really what we're finding is the perimeter if you ran around the inside most lane. Which for those of you that run track, you know that's a shorter distance than running around the outside lane the whole way, right? It's going to have a different circumference, different perimeter. Okay, so the 2 straight edges are the same regardless of what lane you're in. If you're lane 1, 2, 3, 4, 5, 6, doesn't matter. You're still going to run 100 meters on one side and 100 meters on the other side. Can you get the door for me, Michael? So we'll start by adding 100 and 100 together. 100 plus 100. That's going to give you the 2 straight edge sides. Now for our semicircular sides. You guys just said this is going to make 1 full circle. So why don't we just use 1 full circumference formula? So my 3rd and 4th sides are going to be merged together, and I'm just going to use pi times diameter. Okay. The diameter is what here, Frank? 64. Now, how did you get 64? They give us the radius, don't they? So anytime that they give us the radius and we're trying to find circumference, we got to use the diameter. We just double that radius. And so the diameter here is 64. And so we're going to do pi times 64. Are we going to divide that by 2? No, I mean, you could, but then you'd have to times it by 2 because there's 2 semicircles and that's just going to undo each other. So 2 semicircles makes 1 full circle. Yes. Oh, what is 64 times pi?
64 times, you said 5?
64 times pi.
Oh, 200.6.
Okay. And if you're using the pi button, you're getting something slightly different, and that's okay. I'm going to stick with using 3.14 because I know not everybody has a pi button, especially if you're borrowing one of my calculators. If you want to use the pi button, you probably got 201.12 or something like that. What'd you get, Frank? 0.06. Okay. Then we can add the other straight edges on, which is 200 because 100 and 100 makes 200 for a total length of what? What is one trip around lane 1 gonna be? Someone other than Frank. I've heard too much from Frank. All 3 of you have heard too much from. Addison, can you tell me what 200 plus 200.96 is? It's really just 200 plus 200. That's right, 400.96. And we're going to put meters. And that's 1 trip around the inside track. Now, tomorrow, we're going to look at 2 homework problems, number 17, and there it is again, number 18. You should be able to do the rest of them on your own, but if you cannot, come see me during SLT. Have a great day. All right, we have 2 homework problems I'd like to look at from section 8.2. And so number 17 is the first one. Number 17 says that you run around the perimeter of a baseball field at a rate of 9 feet per second. How long does it take you to run around the baseball field to the nearest 1/10 of a second? Well, they give us how fast we're running. 9 feet per second is more like a jog, but they tell us how fast we're running and ask us how long it's going to take us. We're going to need to know how far we're running in order to answer this question. So we need to know the perimeter of the baseball field. How many sides do you see on this baseball field? Frank? 3. Good. There's a straight edge side here. There's a straight edge side here, both of which, by the way, are 300 feet. Every baseball diamond is different, but this one's symmetrical, so we can assume this other side is 300 feet. And then we have the fence, the outfield fence here, which is in the shape of a circle. Kind of looks like a semicircle. However, if you read there, it says it's 40%, not 50% of a circle. So it's not exactly a semicircle, a little bit smaller. So there are 3 sides. 2 of them we already know are 300. So 300 plus 300. We're 2/3 of the way done. Now we need to find the curved side. Now, if this were a full circle, it would look like this. And the 225 feet they give us here is the radius of that circle. Our circumference formula doesn't use the radius though. Ella, what's our circumference formula to use? Pi times the diameter. Yeah, it uses the diameter. So if the radius of this circle is 225 feet, what would the diameter be, Ella, of the entire circle? 225 times 2. $450. Okay. So the diameter of this the whole semicircle is 450. And of course, we're going to do pi times 450. But again, pi times 450 is going to give me the entire circle. And I don't want that. I only want 40% of that. So Maddox, what is 40% as a decimal? 40%. 0.4, exactly. And what does the word of mean? Times. So we're going to take that full circumference of 450 times pi, and we're just going to times that by, as Maddox said, 0.4 because we want 40% of that circle. We're not going to times it by 0.5 because that'd be a semicircle. That'd be 50%. This isn't quite as big as a semicircle. If you do that, and you can just do it all in one step because it's all multiplication, 0.4 times 3.14 times 450. Not as bad as I thought. 565.2. So you guys are getting, or are you even trying? I know Frank. Frank's like, yeah, I typed it in. So 5, say it again, Frank, what is it? Okay. So if I run around just the outfield fence, that's 565.2 feet. I also want to include the 300 feet base paths on both sides. And so that's a total of 600. And so what's my combined perimeter going to be of the entire baseball field? Addison?
1,165.
Perfect. 1,165.2 feet. Okay. Now, before you start typing answers in, that's not what our final answer is going to be, because our final answer, you can see here, is labeled in seconds. Remember, they wanted to find out how long it was going to take us to run around the field. Now that we know how far that distance is, and we know our speed is 9 feet per second, every second that goes by, we're going to have traveled 9 feet. By the way, 9 feet, someone said in first period, wow, that's really fast. I'm 9 feet from the door. I can walk to the door in a second, right? So I'm probably jogging right now. Okay, so it's not that fast. So I'm probably jogging, but either way, if I'm going 9 feet per second, I need to know how many nines are going to go into 1,165.2. So how many seconds that would be. So what do I need to do to finish this? Divide. Yep, we're just going to divide by 9. Natalie, will you do that for us? Give me 2 decimal places. 6 goes on forever. Okay. Now it said round your answer to the nearest 1/10 of a second. So the reason I had her give me 2 decimal places is I have to peek at that next digit. Is the 6 enough to bump the 4 up?
Yes.
It is. So what is our final answer going to be? 0.5, 129.5. Perfect. So it's 129.5 seconds. So if there's 60 seconds in a minute and 120 seconds in 2 minutes, this will take us just over 2 minutes to jog. And I'm saying jog because 9 feet per second is not very fast. Okay, let's move on to number 18. Number 18 says in example 3, that was this one here, we found out that the perimeter of the inside of the track was 400.96 meters. But in number 18, they want us to find out what the outer perimeter of the track is. So what happens if you're in lane 6 and not in lane 1? Well, it says that each lane is 1 meter in width. That's going to be really important for us because it's going to change our perimeter, because the inside of the track has a shorter perimeter than the outside of the track. So in the last example, I highlighted the inside. Now I'm going to highlight the outside of the track. Now, whether I'm doing the inside or outside lanes, these 2 straightaways are still both 300 or 100 meters. So again, 100 meters and 100 meters. So I know for sure that I'm going to do 100 plus 100. And that's going to give me 2 of my, how many total sides do I have? Zoom out too far. I think I went to outer space. I zoomed out so far. I went into a different section of notes. I zoomed out so far. No, this is our section of notes. I do it all the way to the top. That's weird. Okay, how many total sides do I have? 4. I've got the 2 straight sides, and I got the 2 semicircle, 1 on top, 1 on bottom. Okay, and what do 2 semicircles make? 1 full circle. So this will be easy for us because I don't have to divide by 2. Now, yesterday, when we did this problem, we used 64 for our diameter. but that was the inside. I want the outer perimeter. So do you remember how wide did it say each of those lanes were? 1 meter. There are 6 lanes here. So there are 6 meters here. And there are 6 lanes here. So there's 6 meters there. So if we add 12 to 64, we'll have the diameter of the entire outer part of the semicircle. So what is the new diameter we're going to roll with, Natalie? 76 is our new diameter. So 100 plus 100 plus the circumference of those 2 semicircles is 1 full circle, pi times diameter, or pi times 76. That's our perimeter. So pi times 76 should give us 238.64 if we're using 3.14 for pi and not the pi button, which again, you're welcome to use the pi button. I just know that not everybody has it. I'm going to stick with using 3.14. Add that on to those 2 straightaway sides. What's 100 plus 100? 200 for a total outer perimeter of 438.64. Now it says to round our answer to the nearest meter right there. So would you say, Michael, that's closer to 438 meters or 439 meters? It's 0.6. Yep. Was it 5 and more? Raise the score, right? So 439 meters is what we're going to type here because it wants us to round to the nearest meter. Okay. Now, that means if you're in lane 6, you're running 438.64 meters. If you're in lane 1, you are running 400.96 meters. That is a difference of about 38 meters, right? That's not really fair if you're in lane 1 versus lane 6. So to account for that, what they're going to do is they're going to change the starting positions so that everybody runs the same distance. That's why when you run on the track, you see lane 1, 2, 3, 4, they all start at different spots, okay? So before we get there, let's do part B. Lane 1 is going to be the innermost lane. It's going to have the shortest distance. Lane 2 is the next shortest. Lane 3 is the next shortest, all the way to lane 6. They want us to drag and drop these lanes up here to see which ones are smaller and which ones are, or I shouldn't say smaller, shorter. That's probably a better way of saying it, shorter, and which ones are longer. So lane 5, why don't we start with that? Lane 5 is less than which lane? Lane 6. Lane 6 is the longest one. That's the only answer that goes there. Lane 6 is the only one that's longer than lane 5. Next one. Lane 2 is longer than which lane? Lane 1. It's the only lane that it's longer than because lane 1 is the shortest lane. Okay. Next one. Lane 2 is shorter than lane 3 or lane 5. Could be both, but I can only use my answer once. So let's skip it and go to the next one. Lane 4 is longer than which one? Lane 3, which means that lane 2 and lane 5 has to go there. Process of elimination. Okay. All right, part C. Obviously, we can rule out this one because you can't all have them start at the same spots and have that be a fair race. Because lane 1 is the shortest lane. It wouldn't make any sense to have them run here to here. Whoever's in the first lane has the best chance of winning. They have a much shorter distance to run. So to modify this, would they bump the starting positions up lane 1, then 2, 3, 4, 5, 6? Or would they bump the starting positions of lane 6 up and then 5, 4, 3, 2, 1? Which one of those makes the most sense, Lucas? The 6, 5, 4, 3, 2, 1. You're correct. Yeah, they're going to give whoever's in lane 6 a head start, if you will. I mean, they're all starting at the same time. They're going to bump them up because they've calculated mathematically that those distances will be the same. And it's fair because whoever's in lane 6 has that longer perimeter, so they have to bump it up so they all run the same amount. Otherwise, it would not be fair. Whoever's in lane 1 has the advantage. If you watch the especially the Summer Olympics, where there's a lot of track and field events, you'll see them, if they're running just like a 100-meter dash, they'll all start at the same spot. Because for 100 meters, you can all start at the same spot and end at the same spot. But when they start doing the full rotations around the track, running around the track, they have to start those different starting spots. Okay. Any questions? Okay. If you have other 8.2 homework questions, come see me during SLT today and we can talk about the ones you're stuck on. There weren't too many homework questions in last night's homework. I'm not sure if you noticed that. There weren't too many of them because each one has different parts to it, right? So if you're stuck on one part of that problem, come talk to me so we can finish it together. Okay. What I need you guys to do now, though, is download the 8.4, our last section of notes, and we'll be done with chapter 8 notes, and then we'll just spend time reviewing next week. Okay, it's a very quick chapter, but a very important chapter.